Pain-related avoidance behavior majorly contributes to chronic pain disability, yet existing paradigms often lack ecological and construct validity by employing an instructed and low or no-cost avoidance response.
Our paradigm tackles these limitations by allowing investigation of the ways in which avoidance is naturally learned and reinforced, and by incorporating a cost to the avoidance response.
Our paradigm can be uniquely used to explain the processes underlying the learning of pain-related avoidance behavior, how this behavior becomes disabling in chronic pain, and how it can be mitigated.
Place a computer in one room or section for the researcher, and place a large television in a separate room or section for the participant. To prepare for a test session, have everyone disinfect their hands upon arrival to the lab. Have the participant sit in a chair with armrests, approximately 2.5 meters from the television screen, at a comfortable distance of approximately 15 centimeters from the sensor of the robotic arm. After obtaining written informed consent from participant, fill the center of each electrode with conductive electrolyte gel, and use a strap to attach the stimulation electrodes over the triceps tendon of the participant's right arm. After explaining the calibration procedure, ask the participant to rate each stimulus on a numerical scale from 0 to 10, with 0 representing I feel nothing, and 10 representing the worst pain imaginable. Turn on the stimulator, set the intensity to 1 milliamp to start,